This is the explanation of extraction part 2 by Mira. The purpose of this experiment is to examine the presence of basic or acidic or neutral components in the mixture, and these components were separated by extraction and then they were identified. The physical properties of the chemical substances were used. First, diethyl ether. The molar mass is 74.12 grams per mole. The melting point is negative 116.3 Celsius degrees. The boiling point is 34.6 degrees Celsius, and the density is 0.7134 grams per centimeter cube. The second chemical substance is hydrochloric acid. The molar mass is 34.46 grams per mole. The molar mass is negative 114.22 degrees Celsius. The boiling point is negative 85.05 degrees Celsius, and the density is 1.490 grams per liters. Last but not least, the sodium hydroxide. The molar mass is 39.997 grams per mole. Melting point is 318 degrees Celsius. Boiling point is 1338 degrees Celsius, and the density is 2.13 grams per centimeter cube. Materials and safety. Diethyl ether is extremely flammable, and it is an irritant to skin, and no eye contact and no ingestion or inhalation. For disposal, it goes to the non-halogenated bin. For hydrochloric acid, it is extremely corrosive, irritant, and totally avoid skin contact, and no ingestion or inhalation. Disposal goes down the sink. While for sodium hydroxide, it is hazardous to skin, avoid eye contact, and it's extremely corrosive, so no ingestion or inhalation. For disposal, it goes down the sink. For glassware, first, extraction of the basic component. The student started with dissolving 100 milligrams of the unknown in 2 milliliters of diethyl ether. Then, she added 1 milliliter of 5% HCl, and she drawn off the bottom layer in a second tube. Then, she proceeded with the back extraction of the combined HCl layers with 1 milliliter of fresh ether, and then she drawn off the ether layer and it added to the original ether of the unknown mixture. HCl extracts are treated with 10% sodium hydroxide solution until it's basic and tested by blue litmus paper. Then, if a formation of a precipitate happens, then this means that there is a basic component in the mixture. The student then tested for the acidic component. She started with extracting the original ether solution with 3 1 ml portions of 5% sodium hydroxide to a new centrifuge tube. Back extract of the sodium hydroxide with 1 milliliter of fresh ether and acidify with a 10% hydrochloric acid. If a precipitation forms, that indicates that there is an acidic component and it can be separated by vacuum filtering. Then, the student started to isolate the neutral component. The student then separated the neutral component by washing the original ether with 1 milliliter of water, followed by drying the ether layer with a drying agent, such as sodium sulfate. Then, the ether layer was gently removed by heating the original solution on a steam bath. Data. For unknown 14, the acidic component was ptolene, while the neutral was benzyl. For the melting point, for the neutral, the final temperature was 99 degrees Celsius, while for the acidic component, the final temperature was 178 degrees Celsius. And here are the equations that I based on my discussion. In this lab experiment, the student will examine and demonstrate the influence of pH on the solubility of an unknown mixture that contains basic, acidic, or neutral components, as they will be separated by the method of acid-base extraction in a separatory funnel due to their differences in solubility. In order of this type of extraction to take place, the two solvents should be mostly insoluble in one another. To begin with, the student extracted the basic component, the assumed presence of ammonium salt, which is produced by the protonation of an organic amine by the treatment of HCl, is soluble in water, but not in organic solvents such as ether. The student concluded that the ammonium salt of a protonated amine can be deprotonated by the addition of the base, such as sodium hydroxide, which will cause the solution to be more basic and form precipitation if there's any basic component present in the mixture. The solid can be collected and filtered through vacuum filtration. Secondly, the students started testing for the acidic component by treating the possible present carboxylic acids with dilute sodium hydroxide. The acidic component will be deprotonated, forming water-soluble salt, yet it is insoluble in the organic compound ether, which will residue at the aqueous layer. On the other hand, when the basic solution is then made acidic upon the addition of enough HCl, which will be reprotonated, the salt will be converted to the original carboxylic acid, which isn't water soluble, and thus can move from the ether layer into the aqueous layer. If any precipitation forms, crystals can be collected by vacuum filtration. The student then tested for the presence of the neutral component, which is neither acid nor basic. Since neutral compounds are soluble in the organic layer ether, they are able to be recovered in their solid form by drying the organic layer to get rid of all the water absorbed by the ether by drying agents such as sodium sulfate. Then the solution is heated on a steam bath, which will evaporate the organic solvent, which leaves behind the neutral component. If a precipitation formed, then a neutral component is present in the mixture. The student then concluded that the difference in solubility properties allowed them to separate the mixture containing acidic, basic, or neutral components and identify the unknown by examining the melting point of each extracted component. For errors in techniques, the student followed the instructions carefully to avoid any technique errors. However, one of the biggest errors that might have faced the student is to contaminate the sample, which will affect negatively the mass of the collected components, also not allowing enough time for the ether to evaporate completely or when drying the ether, which will falsely increase the mass as water is still trapped within the solution. Another error would be reading off the thermometer wrong during determining the melting point, which will lead to false identification of the components of the mixture.